Alright, welcome back guys. So this is part 2 of the first lesson. Here is the answers to that first part. So number 2, number 5, number 3. Those are the 3 that I asked you to do by yourself. You can double check those. We already talked about where the parabola is going to open up. So now we're going to talk about this part. So next page, it says find the solution to each quadratic function. Then find the vertex and axis symmetry using the formulas. So the first thing that I want you to do, when it says find solution, we're going to change that to factor for right now, so we can see a pattern. So I want you to look at this, and I want you to factor it. And we've done this before, so what's going to multiply to give me 8 to add up to 6? For list of my factors, I know it's 2 and 4, so I'm going to rewrite this as x plus 2, x plus 4. Now, we're going to find the vertex and the axis of symmetry. Your vertex, to do that, we still need to use negative b over 2a. So I'm going to say x equals negative 6 over 2 times 1. So it's going to be a negative 3 for your x value. So if that's negative 3, I got to plug it back in to find my y value. So negative 3 squared plus 6 times negative 3 plus 8. You're going to get 9 minus 18 plus 8, which ends up being negative 1. So your vertex is negative 3, negative 1. Which means my axis of symmetry, which I'm going to abbreviate as AOS, is x equals negative 3. So we're going to do that for all of these. If you do this one, I want you to challenge yourself. Try and pause the video and do the next two. So we're going to factor them first. So if I factor it, this one I got to factor out a 2 first. And then I'm going to rewrite it as x plus 2, x plus 4. I'm going to find my vertex. It's going to be negative 12 over 2 times 2 for my x. So my x is negative 12 over 4. I get negative 3 for my x. However, I want to plug that back in and solve it. So 2 times negative 3 squared plus 12 times negative 3 plus 16. So I get 9 times 2, which is 18, minus 36 plus 16, which is negative 2. So my vertex should be negative 3, negative 2. Which means my axis of symmetry is x equals negative 3. Okay, last one. What can I multiply to get 3 but add up to a negative 4? If you change it to negatives, you see that it is minus 1 and minus 3, so we factored it. Now we're going to do our vertex. Split this up. You get negative 4 over 2 times 1, which is 4 over 2, which is 2, so that's my x value. Now I'm going to plug that back in to find my y. You end up getting 4 minus 8, which is negative 4, plus 3, which is negative 1. So I would get 2, negative 1 as my vertex. And then my axis of symmetry is x equals 2. So now we're going to match them with the correct graph. So go down here at the bottom, the vertex of negative 3, negative 1 should be B. The vertex of negative 3, negative 2 should be A. And the vertex of 2, negative 1 should be C. So we just matched them with the graphs. What I want you to notice also, another big thing, is whenever we factored it, if I said x equals negative 2 and x equals negative 4, look at that graph. Where does it cross the x-axis? At negative 4 and negative 2. So us factoring is finding the x-intercepts. So that's just a nice little thing to help you out. So this one's also x equals negative 2, x equals negative 4. if you notice, B and A are very, very similar. However, this 2 out front and number 8 kind of makes the parabola skinnier, if you notice that in A over here. See how skinny my parabola is compared to B? And lastly, you're going to get x equals 1, x equals 3. Notice it crosses at 1 and 3. So that's how you would solve it if it said find the solution. We're going to factor it, and then we're going to find the vertex and axis symmetry, which is what we did on the last page. So the last thing I want you guys to do, I'm going to have you do a couple problems. I'm going to do number 10 with you. So it says graph this function. In order to do that, there's a couple ways we can go about it. So a very easy way, or I shouldn't say easy, but an easy way to remember is to make a t-chart, right? And we can start at 0. We can plug it into our equation. So if I plug in 0, I'm going to get 5. I can plug in 1. You end up getting 12. Plug in 2. You end up getting a really, really big number, which would be 4 plus 12, 16, 21. All right, we're not going to be able to graph that, right? So maybe we're going the wrong direction. Maybe we should try negatives. So I'm going to try negative 1. When I do that, I get 0. So let's try negative 2. When I do that, I get negative 3. Let's plug in negative 3. When I do that, again, we're just plugging them into the equation. I'm going to get negative 4. When I plug in negative 4, I'm going to get negative 3. Do you see how these have repeated? All right, you can plot these, and that would help you graph it. So negative 1, 0, negative 2, negative 3, just down here, negative 4, negative 3, negative 1, 0, negative 2, negative 3, negative 3, negative 4, negative 4, negative 3, and starting to form that parabola shape. I bet if I plugged in negative 5, I would get 0. So when I do that, I get 0, and I could graph it. So now we know what it's going to look like. However, this is probably not the most efficient way to graph a parabola, because it's a lot of guessing, right? And a lot of checking numbers and making sure it's right. So the easiest way is to do what we've done so far. Look at your A. Is it positive or negative? Since it's positive, we know it's going to go up. It's going to make a smiley face. Yes, we already know the answer, but we know the parabola is going to go up, right? Now, let's do vertex form. So x equals negative b over 2a. Negative 6 over 2 times 1 would be negative 3. I'm going to plug that in, and guess what I'm going to get? Negative 4. So negative 3, negative 4 we know is our vertex, which is a lot easier than guessing and checking on a table. This is not wrong. You can do the table. It just takes a little bit longer sometimes. And then I want to probably find my axis of symmetry. This is why we talk about this, guys, because if you do your axis of symmetry, I know if I plot one point on the other side of that line, then another point on the other side, the same distance away, is going to be at the same value. So let's say, for example, I plugged in negative 4. We already know the answer. I get negative 3. So negative 4, negative 3. I plot that point on my graph now. Now, how far away is that from my axis of symmetry? It is 1 unit away, but it's to the left. So if I go 1 unit to the right, I can plot the same exact point. Now let's plug in negative 2. When I do that, I get negative 3. Let's plug in negative 1. I get 0. So kind of repeat coordinates there just to show you. Negative 1, 0. Right, if I plot that, how far away is that from axis of symmetry? Well, it's 1, 2 units to the right, so I can go 2 units to the left and plot my point. Now my parabola should go up. I should have a vertex down there at the bottom. Should be my lowest point. Does that make sense? Does that go with everything we've learned so far? It does. So now I just got to double check my answer. You can graph it on Desmos to double check, make sure it's correct, and it is. So what I want you guys to do is I want you to use this information, and I want you to solve 11, 12, and 13. When you do that, I want you to take a picture of it, and then upload it to Classroom. That'll be your assignment for participation, and that way I know you watched the videos. The last thing I want you to do is there's a short assignment on Pearson, about 6 questions, that I want you to complete as your official homework, and that'll be your first lesson back. If you have any questions, please email me.